We're looking at topic 5.4, example 3, identify an extraneous solution. So let's go ahead and solve this equation. I need to isolate x. Everything is underneath this radical, so I need to undo the radical, undo the square root. Index is 2, so the inverse is to square it. I'm going to square both sides. I am now left with 3x minus 2 equals. I'm going to go ahead and expand x minus 4 squared. Remember, this is a perfect square trinomial. This is one of your polynomial IDs. So this breaks down to x squared minus 8x plus 16. And if you don't remember that polynomial identity, don't forget you can still just go x minus 4 times x minus 4 and go ahead and FOIL that out. My next step is going to be, let's subtract the 3x. Let me write this down. We're going to do this in one step. Minus 3x from both sides. And I'm also going to add 2 to both sides. I now have 0 equals x squared minus 11x plus 18. And now I'm going to factor. I can drop my x's in. My c value is positive. That means my signs are the same. Middle tells me what they are. They're both going to be negative. Two numbers, when I multiply them, I get positive 18. Add them, I get negative 11. I'm thinking negative 9 and negative 2. Applying your zero product property to solve, x minus 9 equals 0. Here x equals 9. And here x minus 2 equals 0. X equals 2. Now we have two solutions, but one of these, or both, or none, might be extraneous solutions. So that would be an x value that maybe pops out here. But if you were to plug it back into your original equation, it would not create a true statement. So let's take a look at x equals 9. I'm going to go back to my original, and I'm going to check. X equals 9. So I have 3 times 9, square root of 3 times 9 minus 2. Does that equal 9 minus 4? I have 3 times 9 is 27 minus 2. This is the square root of 25. Does that equal 5? And I think we can clearly see, yes, it does. This is 5 equals 5. That is a true statement. Let's check x equals 2. Square root 3 times 2 minus 2. Does that equal 2 minus 4? 3 times 2 is 6 minus 2. That is going to be the square root of 4. Does that equal negative 2? Well, square root of 4 here is 2. This is not true, so that means x equals 2 is an extraneous solution. Let's take a look at the triads. And again, I always recommend, if you missed class, you can pause the video, jot these down, try them, and then come on back and see if you did them correctly. So here we go. On A, I've got everything underneath this radical. My index is 2, so I'm going to square both sides. I get x squared equals 7x plus 8. And I'm going to subtract everything, move it over to the left. X squared minus 7x minus 8 equals 0. And now let's factor. I'm going to drop my x's in. C value is negative, signs have to be opposite. Two numbers, when I multiply them, I get negative 8, but if I add them, I get negative 7. I'm thinking 8 and 1, so the 8 would have to be negative and the 1 would be positive. I'm going to go ahead, I'm going to skip showing it, but we can use the zero product property to solve. And again, x plus 1 equals 0. Well, that means x equals negative 1. And here, x equals 8. And now let's check. So x equals negative 1. Does negative 1 equal the square root of 7 times negative 1 plus 8? Negative 1, put a question mark up there. 7 times negative 1 is negative 7 plus 8. Well, we get a negative 1 equals a positive 1. This is no. So x equals negative 1 is extraneous. Let's check x equals 8. Let me see if I can squeeze it in here. We have 8 equals 7 times 8 plus 8. 8 equals 7 times 8 is 56 plus 8 is 64. Does 8 equal the square root of 64? Why, yes, it does. That means x equals 8 is our solution. X equals negative 1 is extraneous. Let's take a look at B. And again, I'm going to undo the square root first, so I'm going to square both sides. X plus 2 squared, that is x squared plus 4x plus 4 equals x plus 2. I'm going to subtract the x and subtract the 2 from both sides. We do that in one step. X squared plus 3x plus 2 equals 0. And now let's factor. I'm going to drop my x's in. My C value is positive. That means my signs are the same. Middle term tells me they're both positive. Two numbers, when I multiply them, I get 2. When I add them, I get 3. Well, that would be 2 and 1. Applying your zero product property, that means here we have x equals negative 2, x equals negative 1. Now let's check these. Negative 2 plus 2, does that equal the square root of negative 2 plus 2? So does 0 equal the square root of 0? Well, yes, it does. That one is good. X equals negative 1. Negative 1 plus 2, does that equal the square root of negative 1 plus 2? Negative 1 plus 2 is 1 equal negative 1 plus 2 is the square root of 1. 1 equals 1. That is also true. So in this instance, both of these solutions work. There are no extraneous solutions in this problem.